Hello and welcome to E233. I'm your instructor, Gregory Myers. This video, we're going to take another look at function pointers. This video is part of a larger series of videos that are focusing on pointers and how we can use addresses in C. Specifically, this video is going to focus on how we can take a process like exporting the values from a function and extend it essentially to handle any function as long as that function adheres to a function signature. For this example, we're going to focus on functions that accept a double input argument and return a double output argument. This video assumes that you watched the earlier video on function pointers 01, and we'll build on that example. And we are also going to introduce a little bit of file IO. So to begin with, go ahead and obtain a copy of your function underscore pointers underscore 02 snips file. And you'll notice if you've done the earlier example that it is very similar and that I've provided to you a functions underscore 01 or function underscore 01 and function underscore 02, both of which accept a double and return a double. We also have our void function underscore pointer underscore 02, which accepts no input arguments, that essentially acts as a mini helper to our main, and then the function itself that we're interested in driving. In this case, it's going to be our export underscore function underscore values. You'll notice that the first argument to this function is in fact a pointer to another function. And if you recall the signature from the earlier example, we accept a function that accepts a double as an input argument and returns double as an output argument. That's the only limitation in this example. We also provide an xmin, an xmax, n being the number of points that we wish to provide. And then additionally, now we have a file name and then the delimiter. You'll notice that the file name is a character vector or character array, and the delimiter is a single character. And the idea is I wanted us to see a little bit of variety in our example. So to begin with, go ahead and copy over the function prototypes. If you've already done the earlier example, you will only need the function underscore pointer underscore 02 and the export underscore function underscore values because you have already completed the other two. And we can go ahead and copy over the code that I've provided for you as well. Once again, no need to copy over your function underscore 01 and underscore 02 as it was provided in an earlier example. At this point, you can go ahead and close out your snips file. We want to go ahead and update the main to reflect this additional demo. And you could probably cheat a little bit here and just copy and paste from your function underscore pointer underscore 01 and simply change it to 2. And likewise, do the same with the help. And I encourage you once again to simply improve your help when you get a chance so that your user will have a better appreciation for each one of these switches. At this point, go ahead and build it just to make sure that we haven't introduced any bugs. And let's get started on the two functions that we have added. Now, just as in the earlier example, we're going to go ahead and focus on the export function values function first, and then we'll worry about how to drive it. We said in the earlier video that we want to check our input arguments to make sure that there were no problems with them. We wanted to check, for instance, to see if the function pointer or the address that was passed was null. We want to make sure that our xmin is in fact less than our xmax, and that n was greater than or equal to 2. We also want to check to make sure that we have a valid file name as well as a valid delimiter. Now, we won't focus too much on the delimiter because for this example, we're going to do CSV files. We're just going to assume that the user of your executable has actually provided a valid character delimiter, and we're going to focus on commas. You would want to do some additional checking there. But what you can do now is pause this video and then go back to the earlier example where you were simply displaying the function values to make sure that you're comfortable with how this is set up. And so we'll begin here with identifying a results variable. We'll say that our results are going to be equal to exit success optimistically, and then we are going to return our results. At this point, we want to start triaging each one of the arguments to check to see if they're valid. We'll start off to see if our F was null. And if it's null, then we simply want to print a message to the user that says error, invalid function, followed by a new line. And more importantly, what we want to do is we want to say results are now equal to exit failure. Likewise, with the xmin and xmax, we want to write it in such a way that we want to catch any mistakes. So in this case, if our xmax was less than or equal to our xmin, that's when we have a problem. And once again, provide a message back to the user that says error, xmin must be less than your xmax. And you optionally can go ahead and provide some additional information like those values. In this case, though, we're just going to focus on the fact that the results should now be exit failure. Continuing with this, else if, and if our n is less than 2, we said that that was going to be a constraint, that we had to have at least 2 data points. If that's not the case, print f, error n must be greater than or equal to 2. All right, and then once again, results equal to exit failure. Additionally, we can do some error checking on the file name. And what we can do here at the very least is we can check to see the length of the file name. And if the length of the file name is equal to 0, then we have a problem. And I would actually make an additional argument that you cannot have a file name shorter than 3 characters. 3 characters would be a name for the file, the period that separates the file name and the extension, and then a single letter for the extension. Once again, that's getting a little more sophisticated. At the very least, we want to make sure that the string length is not equal to 0. Or at this point, then printf, error, invalid file name. And we definitely want to come back and revisit this one. But for now, we'll say results equal to exit failure. And then, as I said earlier in the video, we really want to elaborate a little bit more on the delimiter. For right now, though, we're going to assume that the user has passed a valid delimiter, a valid single character. The way that you would go about doing this is simply look at the ASCII values and make sure that it is a commonly used delimiter for a file. In this case, we're going to focus mainly on CSV files. Now, just like in the first video, we want to go ahead and create some temporary variables here. One is going to be our x delta. One is going to be our x current, y current, integer for our index. And some of these can be simplified depending on whether you use a different style of for loop or a while loop. But in this particular example, we will have an additional variable that focuses on the file name. And that means that we have to have a file pointer that we're going to call output. And the idea is that we should be able to open that file for writing. And if we cannot open the file for writing, there is no point in continuing. So the first thing that we want to do is we want to attempt to open our file name. And we want to open it for writing. And every time you open a file for either reading, writing, or appending, you simply check to see if that file pointer is in fact not equal to null. And so I start off looking to see if it is null. And if it is null, we simply provide a message back to the user that says error, failed to open the file for writing. And I would actually take the extra step here now and then go ahead and provide what that file name is. And we'll put it in %s, followed by a new line. And then what we'll do is we'll simply go ahead and put in the file name in that placeholder. Either way, our results, once again, become exit failure. However, though, if we were successful in opening the file, in other words, we ended up with a non-null file pointer, we simply go down the else branch of our tree. And under the else branch, what we'd like to do is where in the earlier example, we printed to the console. Now what I'd like to do is I'd like to set up a for loop that simply loops through all the potential values and uses fprintf to write them to the file. Remember that our goal isn't to have some fancy header or anything like that. We simply just want to have the contents of the file be the X and Y values that we can use then later on. So we'll start off with our for loop using our index variable. So for index equals to 0, index less than n, index plus plus. And then what we can do now is we can have a x current equal to the x min plus our x delta times our index. And as I said in the earlier video, we want to make sure to note there could be round off issues here. Just be aware of them. We're not going to address them in this particular example. We now want to go ahead and call our function f. Remember that that is the address of whatever function is passed. And so in this particular case, let's assume that it's sine and we're passing values from 0 to 2 pi. But we want to pass to that function whatever that x current is going to be. And now what we want to do is we want to use our fprintf, and we want to pass it the output file pointer, and then very carefully construct a format spec to accommodate that. And we'll try a little variety here. We're actually going to say %8.4f for the x value. We're going to put in a %c that is going to indicate the delimiter, followed by another %8.4f, followed by a new line. And so our first one is going to be the x current. The second placeholder is going to get the delimiter. And then the third placeholder is going to get our y current. Now, just for a little bit of variety, as you saw earlier, we could also go ahead and include the index. I'm going to include this here as an example, in which case you once again have the output. We would simply go ahead and provide another placeholder for %d, followed by %c for the delimiter. Then the same that we saw earlier, the same format spec of %8.4f, followed by another %c, followed by %8.4f. and a new line. And at this point, we just simply have more values to plug in those placeholders. So it'd be the index, the delimiter, the X current, once again, another delimiter, and then the Y current. Hopefully you are starting to see the pattern here. Now you want to pick one of these two as well as a valid format spec. The only comment that I want to make regarding the format spec that you choose is you do not want to arbitrarily insert some additional spaces. That'll actually defeat the purpose of us having such a fixed format spec. In other words, when we start reading in the data. At this point outside the for loop, once you've iterated through all the values, you need to remember to close your output file pointer, or you will have a problem in later runs of your executable. And we'll go ahead and build it just to make sure that we have no problems. And let's now focus on how to call our export function values. And what we're going to do is we're going to look at having a little additional logic in this helper function that will allow some flexibility in what can be called. And so the first thing that we want to do is we want to set up a results integer to capture the output of the export underscore function underscore values. Remember, that will be either success or failure. And then we also want to employ the same trick that we saw earlier, where we will have a pointer to a function that accepts a double input and returns a double output. Essentially, this is the variable then that will hold the address of the sine function, the cosine function, or one of our demo functions. At this point, what I'd like to do is I'd like to create one additional variable that I'm going to call function underscore name, and I'm going to make it pretty long so that we've got some flexibility. And the idea here is that unlike in the earlier example where I hard-coded in the sine, cosine, and our helper function, is like to allow the user then to pick which function they wish to call. I'm also going to take a step further, and I'm going to create another variable called filename, and I'm also going to make it quite long. And for consistency's sake, I suppose I'll drop the underscore there. And the idea here is that I'm going to ask the user which function they would like to pass to our exporter. Well, to do that, we first want to have a print statement that says, please enter a function, and probably need to provide at least a little bit of help to the user. In other words, to let them know what is available. So how about if we make it look nice here, we'll say sine of x, cosine of x, function underscore 1, and function underscore 02. Now, we need some additional validation in here. We probably want to consider writing a while loop such that while the user does not enter in a valid function, we keep prompting them. Once again, we're going to keep it simple, and that we're just going to have a scanf then, and we accept in the form of a string back from the user the name of the function that they wish to call. Now, one of the things that we probably want to go ahead and do here, I want to pass the address of that, probably want to go ahead and drop the X just for confusion's sake and just for simplicity's sake. You'll see why I'm doing this in just a second. So initially wanted to put that in there, but you'll see it'll simplify it a little bit here. All right, now what we want to do is we want to look at whatever the user entered for the function name, And we want to use string compare I to compare this with one of the options we wish to handle. One is going to be the sign function. And essentially what we're doing here is we're building a little mini triage, much like what we had in main. And we'll do else if string compare I, function name, cosine, else if string compare I, function name, function underscore 01, and might as well go ahead and copy and paste for our function underscore 02. And then if we get down here, we should simply have an else. This is printf error function not handled. And once again, you can probably at this point see multiple different ways to go about doing this. Now, underneath each one of these branches, should the user have typed in one of the functions that we wish to handle, we simply want to make a call now to our export underscore function underscore values. And in this case, what we're going to do is we're going to say results are going to be equal to export function underscore function underscore values. And what we're going to do now is we're going to give it the address of the function. Now, we could go ahead and specify the function itself. We could specify an xmin and an xmax. In other words, we could simply just hard code these. Or what we can do is we can prompt the user for additional information. So printf, please enter xmin. Please enter an xmax. And please enter an n. And then each of these would need the corresponding scanf. And so for the xmin, we would need %lf, and then we'll need the address of an xmin variable, which means we're going to need to go up and create one. An xmax. And then for the n, of course, we need to change the format spec to %d, and we provide then the address of an n variable. So we'll go ahead and add these, double xmin, double xmax, and then int n. Now, we could continue with this. In other words, we could also prompt the user for the name of the function. However, I'd like to do this just a little differently in this case. And that what I'd like to do is I'd like to derive the name of the file name from the function name. And so to accomplish this, then I actually am going to create one additional temporary variable, and this will allow for us to have a little more flexibility in here. And so we ultimately would want to validate all of the values, but we will create a temporary, or not a temporary, but rather a local variable called valid. And we'll start off assigning this optimistically as valid equal to 1. And then what we can do here is if under any of these circumstances where, for instance, the user enters in an xmax that was less than the xmin, or an n that was less than 0 or less than 2 rather, then we would invalidate the valid variable by simply setting it equal to 0. What we're going to do, though, is we're going to be rather optimistic here, and we're going to assume that the user is entering in values for this one that are correct. And the only time that we have a problem then is when they enter in a erroneous function name, in which case we simply say valid equal to 0. Now, to paraphrase what I've said earlier, we just want to mention that we should probably validate all of our input arguments. And I'll leave that for an exercise for you to do. But the point is that then what this does is this allows for us to use a function called Stringcat. And our Stringcat function will allow for us to concatenate to a existing value or variable another string. And so the idea here is that I would use our Stringcat function to concatenate to our filename function the name of the function itself. And then what I can do now is I can use that once again, Stringcat and the file name, and I can append to the end of that .csv. And so we can repeat this for any of the options that we wish to handle. And what this does is this allows for us to have a more streamlined approach, more consistent approach of setting our output file name and make it relate to the function. So the idea is that our output for sine should be sine.csv. The output for cosine should be cosine.csv. The output for function underscore 01 should be function underscore 01.csv, and so on. Now what we want to do is we simply have an if statement that says if valid is equal to 1 or true, then we make one call regardless of whichever function was called to our export. And so we'll simply say results are equal to export underscore function underscore values. We pass to it the function variable. We pass to it an xmin, an xmax, the n, the file name, as well as the delimiter. Now we said we're going to just simply hard code that as a comma. Now, at this point, then we can simply do a printf and have results followed by %d in a new line and whatever the value is for the return of our export underscore function. Now, if you've been following along so far, you'll note that there is one other additional thing that we have to do that we saw in the previous video. We've handled the function name and we've handled the file name. What we did not, in fact, handle was setting the value for f. In other words, assigning the value to f of the address that we wish, of the address of the function, rather, that we wish to run. And so at this point, under each one of the branches of our if statement, we simply say f is equal to sine, f is equal to cosine, f is equal to function underscore 1, or f is equal to function underscore 02. Basically, what we're doing is whatever the address is of the function that we wish to run is now going to be assigned to the variable f, and we pass it then to our export underscore function underscore values. Now, hopefully this example really reinforces the reason why we would want to do it this way, as opposed to rewriting our export function values a little bit different for each one of the functions that we wish to handle. In this case, simply we expand the triaging of our function names, and that's part of the reason why I'm de-emphasizing the additional validation. So let's go ahead and build this. If we don't have any mistakes, we should be ready to run it. We'll go ahead and change our function underscore pointers underscore 01 to underscore 02 from the earlier video. And you'll see that I have my little mini help here that allows for us to pick a function. I'm going to put in something that we had not anticipated handling, In this case, it's still going to go ahead and prompt me because of the order of our logic. But you'll see that ultimately it says error function not handled. We run this one more time without attempting to break it. There's our sign, 0. I'm going to go ahead and put in 6.28 as an approximation for 2 pi. I'm going to put in 33 data points and an error that says failed to open this file for writing, which means that we have some sort of issue with passing the value of the file name variable. And so what we can do here is we can check to see real quick by printing out the value of the file name. I think I know where the problem is here. So our problem stems from the fact that we did not initialize our function name and our file name. And if you saw in the earlier command window, you saw the nonsense for the file name. It was because our file name was not initialized. You simply want to set these equal to empty double quotes. And at this point, if we go ahead and build it, and we can go ahead and rerun this. Do 33 values. You'll see that we also have a problem with our export function. Most notably is that it has nonsense in it. And if you come into the export function itself, you'll see that we calculated our x current from our x min and our x delta times our index. However, we did forget to actually calculate our x delta. And so what you want to do now is you want to remind ourselves that our x delta is going to be equal to our x max minus our x min divided by n minus 1, where n is the number of data points that we wish to have. We go ahead and build this. Pick the sign function, x min of 0, x max of 6.28, 33 for our n, and now when we look at our sign.csv file, you'll see that it is a 2-column, comma-separated file with the first column being the x value and the second column being the y value. You'll note here that this value right here is just a reflection of our poor approximation for pi. You can handle this a couple of different ways. You can actually prompt the user for the number of decimal points they wish to handle, and then build your format spec based on that. Or what you can do is you can simply provide more precision in your input arguments. No matter what, at this point, we are done with this particular example. Hopefully this made sense to you. And as always, if you have any question, comments, or concerns, don't hesitate to email me, and thank you for watching.